reduced conflict objects. Okay? So for example, there's a dictionary that two sessions can add elements to the dictionary as long as they use separate keys. And GemStone will not treat that as a conflict. Or, let's take a simpler case, an RcIdentityBag. So with an RcIdentityBag, two sessions could add the same object to the bag at the same time and not have a conflict. This is a useful thing. GemStone provides this RcIdentityBag. Why is it that an RcIdentityBag doesn't get conflicts, but an identity bag does get conflicts? The internal implementation of an RcIdentityBag is that an RcIdentityBag has an instance variable for each session. So if you could have 100 sessions, then an RcIdentityBag has 100 instance variables, and each of those instance variables contains an identity bag for each session. And if you want to count how many times an object is in the collection, you have to go through each of the children and look for the object. So it could be once in session 1, twice in session 2. So it will be in the bag 3 times. So each session adds and removes from its own collection.
It's expensive.
So there is an overhead associated with RC collections.
This is both for the regular and the RC cases?
No, for the regular case, it's one object that has all of them. Because then, if 2 sessions add at the same time, there'll be a conflict. And it will simply say, oh, this object is an identity bag. 2 sessions attempted to modify it. If 2 sessions attempted to modify it, the second one fails.
So if you have 3 sessions which have done something, when the session ends, is there like a canonical one which it then all gets merged into?
Yeah, there's some optimizations in there that says, okay, now let's try to catch up so that we don't have, so that each of the other sessions doesn't have lots of things in it. And so then you have one main bag, and then you have other auxiliary bags. And if the auxiliary bags are mostly empty, then it's cheaper to check them all. But you still have to check them all, at least to see if they're empty. Because you could add in one session and remove in another and not conflict, it turns out each session part of the RcIdentityBag has to keep track of not just of additions, but removals. And so if it exists in the main one, the removal can't be done to the main one, it has to be done to the child. So it turns out, in response to your question, you raise the idea that maybe there's a way around commit conflict checking, that you could tell the system that this object is okay. And the answer is no, there isn't. At the low-level, virtual machine level, object conflicts are per object. And what you're doing, if you want to have the reduced conflict classes, it looks like an identity bag, and it behaves like an identity bag, but it's not an identity bag. It's a collection of data structures that manage something that looks like an identity bag, but does it in such a way that conflicts are avoided. On an RcCounter, there's not just one integer that gets counted. There's a counter for every session. And the current value of the counter is the sum of the counters for every session. On an RcQueue, there's a queue for every session. And the logical queue is a combination of all of them taken out in the proper timestamp order. RC collections are very useful and very valuable and should be used in certain situations, but have a certain overhead.
So, but in your one where you have the RcIdentityBag, right?
Mm-hmm.
Where if you put object A in one transaction, while at the same time removing I guess an object A that's already in there. So you would end up back with just one object A, but it's a different
It's in a different
A
session.
of itself.
Yes.
And then it commits. Oh,
Yes, yes.
that just seems really weird when you think about it, but it makes sense. But
Well, it's really weird, but it's the object. If you start, at a point in time with object A in this collection, someone removes it, someone else adds it. The person who removed it thinks during their transaction that there's 0 of them. The person who added thinks during their transaction that there's 2 of them.
so for like
And so by the time both commit, someone who looks at a commit record that comes after the second commit, or is the second commit, their view of the database will be that there's one object in. And if you serialize the transactions, it doesn't matter what order they happen in. You can start with 1 and remove it, have 0, add 1 and have 1. You can start with 1, add 1, have 2, subtract 1 and have 1. And kind of, again, if you're studying databases and transactions in computer science, the nature of optimization of database transactions is allowing things to happen in parallel, but giving the illusion that they happen in series. So as long as happening in series and the order is independent, then we can allow them to be in parallel. And so RC collections are weird, but they accomplish this goal. For an RcQueue, each time something is added to the queue, when it's added, it gets a microsecond timestamp. Then when we go to remove things from the queue, we remove them sorted by the microsecond timestamp. Now, if someone adds something to the queue and does not commit the transaction for a long time, then something that got added afterwards but committed before will be visible and will get removed. So an RcQueue does not guarantee that things will be removed in the order they're added. It guarantees that within one view, they will be removed in the order that they were added. But if you take a long time to commit, then other things might get processed before you commit. But as soon as you commit, yours will be the earliest one visible and will get picked next.
So if I added it to the queue like 10 minutes ago, but I don't commit it till now,
Yes.
it will appear in the queue for 10 minutes ago instead of right now.
When it finally appears in the queue, it will have an add timestamp that represents 10 minutes ago. It's largely implemented in Smalltalk. The RC approach is to say, well, we'll pretend that this is one object when it's really a tree of objects, one for every session.